All right, we're back for another screencast tutorial. Um, I'm going to start breaking these up into smaller sections and composing them together. This way it's a little bit more cohesive and I'm not spending too much time. The last tutorial screencast was like 30 minutes. It's way too long. So for this one, what we're going to do is go ahead and actually set up a basic scene, having a floor and a scaled sphere to make it look kind of like an ellipse, an ellipsis, and then add some controls inside the scene through the scene editor or the scene composer with the jMonkey SDK. So the first thing we're going to want to do is just go ahead and right click on your scenes folder. If it's not there, you can just right click and say new folder and create the scenes folder there. It doesn't have to be named scenes, but that's just for convention. Then you go to other, you right click, go to, redo this, you right click, new, and other. And then we're going to go to scene and empty jMe3 scene. I'm just going to call this level 1. It kicks me down here. I can't do anything about it, like right click or just double click, does nothing. So what you actually need to do is scroll back up. And again, double click doesn't do anything. So you can just right click and say edit in SceneComposer. Okay, so this is a bit archaic in the sense that it's not like someone really thought the UI through, and part of this is it's inside NetBeans, so it's not like you have all this freedom to do those UI stuff. Um, I'm gonna have to show you a couple stuff here. The Scene Explorer is extremely important. This is where we're gonna be adding all of our stuff. And if you don't have that, you can go to Window and go to Scene Explorer. And I think not new geometry settings, it's something else. It's one of these other ones. If you just go through these one by one, you'll eventually get the scene properties here. This will also be important to have. Okay, so first we're going to do is right click on scene, add spatial, primitives, and quad. Now, if you were to add a quad through code, it would actually be standing up straight, and that's because a quad only has two axes, X and Y. They actually they just rotate it negative 90 degrees to be flat as a ground when you're looking through the camera. So make sure you select quad here on your Scene Explorer, and then go ahead and go to scale. We can scale through the interface, so here I can actually select the scale tool, and it gives me some options to scale. But I have some specific numbers I want to enter in, so I can actually just go to the local scale here and just type in 100, 100. Again, there's only two axes, X and Y. So you can't enter anything in for Z, unfortunately. So that's there. It's giving me a nice big one, but I want to move this into the center of it, and I can move it with this tool here too. It's just not very very efficient. I have a specific coordinates I want to enter. That's basically going to be 50 or negative 50, comma 0, comma 50. And that'll center my floor. And right now it says quad, so I'm actually just going to click once on this and rename it to floor. Come on. Why is this not letting me rename it? Okay, I'm just going to right click and rename. Usually you can just single click and wait a little bit and it'll bring up the thing on it. Okay, next thing we're going to want to do is actually add in the sphere. So right click on scene, add spatial, primitives, and sphere. I'm going to go ahead and just rename this to player. And for this, I'm actually just going to go ahead and use the move controls freely. So I'm just going to move it up some, like that. And I want to set the scale of the y-axis to 1.8. There's a reason for this, and it has to do with the actual physics control, the character control that we're going to use. It has some quirks, and I'll try to talk you through those. But for the sake of purposes, we're just about done. All we need to do next is add in a control to the floor. You can either do this through right-clicking, add control, and set you choose static rigid body, or there's a nifty little button here that says add collision shape. It does effectively the same thing. And now it's letting me rename it. So you actually just click it. Floor gets repositioned in the scene graph. I'm not sure why, but the physics control is there. And if you look at it, it says rigid body control. So that's the actual control it's using. And you can still move the floor around if you want to. There's actually properties here that you can set. So if you wanted to change the friction mass and so on, the character control kind of does not always use all of this stuff by itself because it's not using the native rigid body that comes with the bullet physics engine. It's actually trying to do some extra stuff to make it feel more like a character movement than an actual real object. So we could possibly do the same with player, but there's a lot of stuff that happens that goes wrong basically. First is if you did want to do it, you can actually just right click, add control and character, or you can click the make character. Once you do that though, you're unable to move the spatial or the geometry of this. And the reason for that is the control itself has no understanding of what pause, like what a pause state is. Some controls have this, other controls do not. In the example of the rigid body control, it actually has the ability to reposition itself if the spatial geometry is ever moved. So it works inside of this editor, whereas the player character control does not. There is another character control called BetterCharacterControl. It does work in this editor. You can uncheck enable and move your stuff around. Unfortunately, it is meant for first-person views, like a first-person shooter, whereas the character control is meant for a third-person view. Because the character control moves in with the camera, it's a lot of integration that happens. And so I don't know why they named it character control and better character control, but really it is third-person view character control and first-person view character control. There are some minor differences between those two. It's not just the camera. Some of the way that gravity works seemingly works better in the better character control, but you'll be ripping out your hair if you try to do that plus have a third-person perspective or third-person camera along with that control. So I'm just going to leave it there. All you need to do at this point is save it, and then we're going to go ahead and move into the Java code to load the scene and do other stuff. Okay, now that we have our basic scene set up, what we're going to do is go ahead and just wipe out some of this geometry stuff that we're doing manually and having to manually type this in and go back in there. But there was two things I actually forgot to do in the scene that we had just previously edited. So I'm going to go ahead and go back and right click and say edit in SceneComposer. And we're actually going to go ahead and set the material for these. So we're going to choose the floor. The floor material, let's see where this is showing up at. Material, where is it? Okay, so here we have materials. I really don't want to create another material here, so I'm just going to use the red for the floor, and I'm going to go to player and choose the white for the player. So we have red and white. I'm going to go ahead and save this. Come on, stop it. Make sure it's saved. One thing with the Mac is that if I hit like Apple S, it'll try to scale it. Oh shoot. It'll try to scale it. Come on. Set this back to white. So it's one of the things I don't generally enjoy with this. Anyways, back to this. Now that we have a material set, we don't have to do this whole like create a material, assign it to the geometry. All this can go away because we're all doing this through the scene editor that's creating this file that we can just load up. So we can actually just go and say scene equals asset manager load model. Load model, it's all the same as far as what's a scene and what's a model when it's the J3L formats. So then we're going to say scenes slash level 1 dot J30. And let's go ahead and I don't think we need to really have this set as a property or anything else, and just have it as a local, not a field. And we're gonna get a couple of things here. So we're gonna get the player geometry and the floor geometry, and I'll show you why. But let's just go ahead and actually add in the scene. So we're just we're changing the attached child to just pull in the scene, and then we're actually going to go back into this update, and we can literally just delete it because we're not going to do any of this spinning cube stuff and anything else like that. So we're going to hit save, and now you can hit play, and you'll be able to see the scene and the materials that we had set. So continue. There we go. The camera is in a weird position, but here's our scene that we built in the SceneComposer. So much more streamlined than just manually writing the code out for it. All right, let's talk about physics now. Let's go ahead and actually set up the bullet physics engine. And the way that we're going to do that is actually just in this same area. Just call. We're going to create a new field called bullet app state. And this is going to be equal to new bullet app state. Then we're going to go ahead and actually, we're going to turn on debugging for this. And what that lets you do is you'll be able to see the meshes, what's colliding visually inside of your video game. So it's extremely helpful. Set. Now let me create this field first so I can get autocomplete. Set debug mode. Set it to true. And then we're going to attach the state manager. We're going to attach the bullet state to the state manager. Okay. So now this doesn't intrinsically do anything just yet, because if we hit play, we're still just going to get everything and nothing moves. There's two reasons for this. One is that while we're putting controls, physics controls in the scene, it's actually not attached to the bullet app state, and so or the bullet engine. So this is why we have to go back and query the scene and get the geometries from there and go ahead and set this all up. So the first thing we're going to do is probably the easiest. Let's get the floor. So we're going to call this floor equals scene.getChild. And if you named it correctly, it should just be floor, and this is just pulling from the same name that we have here. So whatever you typed for floor, we need to match it as the child name. And I'm just going to go ahead and, why is this not, let me get child. Oh, I'm an idiot. It's local root node, so it's, what? There you go. Because we've added it to the local root node, we're going to go ahead and then get the floor from the local root node. And from here, we can just create a local spatial, since we don't need it as a field. And then we're just going to get the control next. We can get the control and assign it to the physics engine all at once. So we're just going to do bullet appstate.get physics space dot attach or add. And then we're going to say floor.get control. And we can specify the actual control that we use, and you can figure that out again by going to the scene, physics control, and look at, it says rigid body control here. So that's the class that we're using. Rigid body control dot class. Then we're going to go ahead and import that in. could spell that right. Yes. Okay. Import that in. And so that's there. Now we next need to go ahead and set up the character. Let's just put a little note here. Load for and control. I'm going to get the actual player. So same method here, except we probably want to keep this as a field just in case of anything. So we're going to say player equals local root node dot get child. And we're going to call this player because that's what we called it there. And we can confirm just by going back to the SceneComposer and looking at that. Okay. So now that we have our player, let's set this as a field because we may want to access it later. And then player control is also going to be the field. And the way that we're going to set this up is by setting it as the character control. So we're going to say new character control. And we're going to go ahead and import that in. And we're going to set this as a field. This is going to be incredibly important because we'll be doing a lot with that. And now we have to add the control to the player since we didn't do it through the SceneComposer. So player.set, add control, player control. Okay. So now let's go ahead and actually just hit the play button, see what happens. Continue. And we crash. This is because we don't, part of the thing that you need to do with the character control is assign it a collision shape. So you can have a sphere, you can have a box, you can have a complex mesh, which is nice. I mean, this is a lot of flexibility for a character control. So we're going to use the capsule because that's usually the most used one for a character in general. And we're going to get the capsule, we're going to set up the capsule by getting the bounding box of our player, which is the width and height and dimensions, stuff like that. So we got to do a little bit of legwork here. Let's go ahead and first we're actually going to get the bounding box of the player. So we're going to say bounding box equals player dot get world bound, and this is going to be local field. Let me double check something here. So we got bounding box dot get. Yeah, no. So one thing we need to do with this bounding volume is to actually cast it as an actual bounding box class. So let's just change this up. Import the class and let's get rid of all these things that are not used. Okay. So now that we have the bounding box, we're actually gonna get the set up the radius of the capsule by getting the x coordinates. If I could spell this right, radius equals bounding box dot get x extend. So this is just getting us the width of the object. And next thing we do is get the height. So we're going to say float height equals bounding box, and we're going to get the y-axis. And this will give us the height of the capsule. So now that we have the width and height, we can actually set up the shape, the player shape. Equals new capsule shape. We're gonna set the radius and height as the two parameters for the constructor. Set this as a import that set it up as a local. And then we can go ahead and finally set up the player control successfully. So we're gonna put in the shape. We also need to put in the mass of this. This depends on what your world set up as. I'm just putting it as 1. It seems to work just fine. Let's see, we got that. The player control set in. Let's see what else here we got. I think that's about it. So we really need at this point, other than setting control inside the bullet engine. So bullet appstate.get physics space dot add, and it's just going to be the player control. So now 2 things should happen. 1, it shouldn't crash, hopefully. The next is you're going to see the player drop onto the scene, and if all works out well, it won't drop below it. So here you see the floor, and it's not going past the floor. The height is a little too high, but I think that's fine. The way this is set up, you can always adjust it through source code if you want. And because we have debug mode on, you can actually see the collision shape that we've created based off the bounding boxes. All right, so that concludes that. Next thing we're going to do is set up the camera and controls to move the characters and move the camera. So see you then. Okay, so we're going to do this in quite of a big swoop of details here, and just basically getting the camera and disabling the fly cam at this point, because we're going to have a third-person camera set up. We need to get rid of that fly cam. So we're going to go ahead and actually access the fly cam. So fly by camera equals app.get fly by camera, and we're also going to have the camera to app.get camera. And then let's go ahead and set these up as fields. All right, so now that we have that there, what we can do next is, let's see here. Let's go ahead and disable the flyby camera. So we do flyby camera dot set enabled is false. We're then going to set up the chase cam, which is basically going to follow the character in third-person view. So we're going to say chase cam equals new chase camera. And we have the camera already there. That's great. The player, I believe, is the actual spatial. And the input manager is also what we need to handle the mouse movements. And we're going to go ahead and actually set this up as a field. Okay. So now that's set up. We're going to want to do, see how far we can get. Resetting camera. Okay, well, let's just keep trugging through this. We're gonna go ahead and set up the movement booleans of whether you're moving forward, backwards, left or right, or up and down, left and right. So we're gonna set up some booleans here. We're gonna say boolean left equals false, right equals false, up equals false, down equals false. And we also need a walk direction. So after all these controls are pressed, what direction should you be walking in? So private. We're going to have this as a final since we don't need to keep setting up new walk directions, really. We can just change the existing one. Import that in. And then player walk direction equals new vector. Actually, we don't need to say new vector. We can say vector 0. Come on. Okay. All right, so that is set up. Let's see, anything else that we need to do? Character control, we got that. Chase cam set up. We can now assign the input manager stuff. So we have our pause here, yay! But now we're going to start spamming this in with a bunch more stuff. I'm just going to copy and paste this a couple times and say up, down, left, right, and finally a jump key. So up is going to be the W key, down is going to be the S key, left is going to be the A key, right is going to be the D key, so the W, S, A, D. And then jump is going to be space. Okay, now that we have that set up, we can jump to our action listener. And in our action listener, we can go ahead and type some other stuff. So else if name dot equals up. And we're not going to check for key pressed because we're actually going to use that boolean to set the direction to true or false. So we're just going to say up equals key pressed. And I really don't feel like typing this all out, so I'm just going to copy and paste this 4 more times. Actually 5 for the jump. Say down, left, right, and jump. And then this will be down instead of up. This will be left, and this will be right. The reason why we're not actually setting the walk direction in this instance is that the way the control works is it has to wait until the update cycle happens because the walk direction changes instantly all the time. So it's best to wait until that. But for the instance of jumping, we can go ahead and save a little bit of extra typing out and actually just say player control. And then jump. Alright, so we have all that set up. Now we need to do kind of the complicated part, and this is, I'll try my best to explain this as far as what I know about it. But we're going to go ahead and get the camera direction. So we're going to say camdir equals camera.get direction. And we're going to clone that because we're going to modify it and get the cam left equals camera dot get left and clone this. Now I know why we get the camera direction. That's because the way that the camera is looking, you want to be able to figure that out because you want the character to be facing that direction. But you don't want the height of the camera, so we're actually going to say camdir dot y equals 0. And we're going to do the same with cam left. And I didn't set the local variables for this, so go ahead and do that. And then we're going to normalize local, which basically takes the world position in and stuff like that, all this fancy stuff. And just do dot normalize local. And do that with cam left. And then lastly, we're going to set the player, we're going to reset the player walk direction. Dot set 0, 0, 0. So we're resetting all the accesses for that. And then we're going to have some simple logic here. If left player walk direction dot add local, and we're going to take the camera left And these aren't going to be if and else because we actually want to be able to handle every single direction at once if we wanted to. So we're going to say right. Instead of cam left, we're actually going to inverse that. So we're going to negate. And this is going to be up and then down. And instead of cam left, we're actually going to use cam direction. And again, negate this because we are doing it in the opposite. All right, so the next thing we're going to want to do is we have our player geometry. So we can check it if we want. So we can say player, if player does not equal null, so we don't get a crashing in case we ever do something wrong in our scene graph. And here we're going to set the player walk direction to a multiplier. This multiplier is based on what it's going to do is right now we have the where we want to move the object. That's a no-brainer. But we want it to have a certain speed to it. And so this will be, however you set this up, you would want to tweak this multiplier. So you can do mat local, which will take our float and multiply it against each axis, so x, y, and z, rather than us having to type in each axis 10, 10, 10, 10, we can just take it once. And we actually want to do local. Local just takes that 10 number and applies it to itself rather than generating a brand new vector. And then we want to do another multiplication of a local, and we're going to enter in the TPF, and that is to stabilize how quickly you move per frame. I've talked about this in I think it was like the very first or second one, maybe the last one, about why TPF is important. Then we're going to actually set the player direction, so the player control, so where the player is looking, because this is going off the camera module. Dot set walk direction. We're actually going to set the player walk direction. So wherever the camera is looking, we're basically setting it up to saying this is where the camera or the player should be facing. So if you press up and you're looking at the camera in a certain direction, the player should be moving in that direction. All right, so if all is set well, this should work flawlessly, and you'll be able to do several things here, which is fall to the ground, move, don't seem to be moving, jump, I don't seem to be jumping. All right. So what did I do here? I can move my camera around. I just cannot seem to move. So let's see, what did I do wrong here? Ah, the listener. Okay, so you can just keep piling on to the listener here and say like up, down, blah, blah, blah. Or you can actually just repeat that as well. I'm just going to go ahead and repeat this because it's way easier to copy and paste. Okay, let's go ahead and run this one more time. And continue. And now we move up, left, right, down, and we can jump. Now it's a little hard to see you actually jumping unless we put more objects in here, so I can leave that to you to do. And you can actually jump off and fall forever. But yeah, so you just basically set up a little character control, made him jump around, move. The camera follows him. You can use the camera to pan left and right, up and down. And the character will look in that direction as well and move with it. And this is the start of a real game.